Okay, good day again. So this is Francis. This is Harcourt from Harcourt Educational Consult once again. And for my students taking basic mechanics, this is an assignment you have to submit. I think on 13th. Yeah. So we're going to go through this assignment together. Yeah, for submission. So wrap up. Grab your pencil and get your printed document. If you haven't printed it, can you go and print it and come back and play the video? Once again, if you haven't subscribed, can you do so and support me to do more of this? Okay, sorry. So there are two questions in this, and yes, your answers are to be provided in two decimal places. Gravity should be 9.81, like the usual things. So the question one, I'm going to solve the question one and then go to question two. So question one says a cross section of a press for compressing empty cans for easier transportation to recycling plant is shown in figure question two or in figure Q2. In operation, a force P shown in figure Q2, which is this force P, is applied on a actuating bar through or via hydraulic means. The effect of P is then transmitted through the short links DE, DC, and DB onto the piston, which then compresses the contents in the cylinder. If the maximum P of 100 Newton is applied on the actuating bar and the weight of all the parts of the press are ignored. A. Sketch the free body diagram for the actuating bar only. Take the joint at F to be a pin joint. Determine all the external forces that are acting on the actuating bar. Sketch the free body diagram for the joint D and determine the forces that is acting on the link DB. If the piston has a smooth surface type of contact with the walls of the cylinder, what is the magnitude of the vertical force with which the piston presses down the contents of the cylinder? A very simple problem. Okay. Right. So first off, we are going to draw the free body diagram according to the instructions. So the first thing is to sketch the free body diagram for the actuating bar only. And actuating bar is the bar JEF. Okay. So grab your pencil. Um, we can use just lines. You see, can use just lines. So you can have something like this, and then something like that. So at this end here, we have the force DE hitting. We have the force FX, FY, and then we have P here. Okay. The distance from DE to F, the distance from here to here is 20 cm, and the distance from here to here is 70 cm. Okay, so this is the free body diagram for the actuating bar only. So that is A. B. So the B says determine all the external forces that are acting on actuating mass. So all the external forces, we have P, we have force in DE, and then FX, FY. Okay, so I'm going to determine these ones. So what we know is for this body to be in equilibrium or static, sum of forces in the x direction should be equal to 0, sum of forces in the y direction should be equal to 0, and sum of movement at any point should be equal to 0. So I'm going to take the forces in the x direction. So sum of forces in the x direction, going right to be positive, is equal to 0. The force I have what? FDE going to the right plus Fx going to the right is equal to 0, equation 1. And then I will take going up to be positive, sum of forces in the y direction is equal to 0. And the forces in the y direction, I have P plus Fy is equal to 0. So from here, knowing that, so equation 2, right? So P is equal to what? 100 Newton. Therefore, uh, Fy is equal to what? Minus P, which is equal to minus 100. Okay, minus 100 Newton. Okay. So that gives us Fy. So you found one of the reaction forces. What we don't know is FDE and what? Fx. All right. So we know that we can take moment at the point here, right? Because we said taking moment at any point should be equal to 0. So summing, taking anti-clockwise to be positive, summing moment about point F should be equal to 0. So the forces is going to be force times perpendicular distance. I have FDE, which is going clockwise direction, and this one will go anti-clockwise direction. So from the basic concept, clockwise should be equal to what? Anti-clockwise, right? So you can say that FDE times 20. I'm using centimeter because they're going to cancel out anyway. All right, so FDE times 20 should be equal to P times 70. So you can say the FDE is equal to what? P times 70 on 20, giving you 100 times 7 on 2, which is 350. 7, so 3.5 times 100, 350 Newton. But we know, okay, so from here, knowing FDE is equal to 350 Newton, we can say that FDE plus Fx giving you 0 from equation 1, Fx will be equal to what? Minus FDE, which is equal to what? Minus 350 Newton. Okay. Then we go to C. So we have found Fx, Fy, FDE. So we know all of them. The C says, sketch the free body diagram of joint D and determine the force that is acting on the link DB. The link DB is this link, right? Okay, so that, suppose this is my point D. Now, because FDE went to the right, FDE on link D will go to the left. All right, then FDC. So FDC, I mean, you can choose any direction for FDC because you're not choosing one yet, right? So I'm choosing FDC to come this direction. And then FBDB, I'm also making it like this, right? So FDE here, FBD or DB, no, CD here, and then FBD here. Okay. Now we know that this one makes an angle of 67 with the horizontal, so 67 degrees here, and then the other guy makes an angle of 78 with the horizontal. All right, so this is what we have, and from here uh, heading to the first scenario, sum of forces in the x direction should be equal to 0. So sum of forces in the x direction should be equal to 0, taking right to be positive. So I'm going to have FCD. Okay, so if I pick this, it's going to be like this, right? So, yeah, FCD cos 78. Hold on. So this force is going to be like this, right? 78 here. Okay, so if this is FCD, I'm going to have FCD cos 78, and then the horizontal will be what? FCD sine 78. You get it? Okay, the same way for this. So that one, this one too, will be like this. So in your presentation, don't do this, right? Just follow up like this. I'm just showing you how I'm going to get the cos and sine people. So this one to here is 67. So you're going to get the FDB sine 67 and then cos 67 here. Okay, so FCD cos 78 is going to the right, and then you have minus FDE going to the left, and then you have what? Plus FBD cos 67 also going to the right. This should be equal to 0. All right, now you know FDE to be what? FDE to be 350. So we can say that FCD cos 78, let's check that. Cos 78 is 0.2079. All right, 0.2079. So 0.2079 FCD plus cos 67. Cos 67 is 0.3907. 0.3907 FBD is equal to what? FDE, which is 350. Equation 1 or equation whatever. Then you do for the y. So sum of forces in the y direction will be equal to 0 as well. Now in the y direction, I'm going to have FBD sine and then FCD sine. Right. Now this one will come down, this one will go up. So BD will be positive, CD will be negative. So we're going to have FCD sine, which is minus FCD sine 78 plus FBD sine 67 is equal to 0. Right, so here we have sine 78 is 0.9781. So minus 0.9781 FCD plus sine 67 plus 0.9205 FBD is equal to 0. So from here, you don't even worry yourself to solve everything, simultaneously. Just go to your calculator, you go to equations and 1. Your equation 1, you have 0.2078, you have 0.3907, and that is equal to 350. And then the other equation, you have minus 0.9781 and then plus 0.9205 is equal to 0. So we have FCD to be equal to 561.84 Newton, and then FBD to be equal to 597.00 Newton. All right, so we've been able to sketch the free body diagram for the joint D and determine the force action on the link on link DB. So all right, so from here we know that FBD is equal to what? 597 Newton. 597 Newton. So now, what is the next question? D. If you want if the piston surface type, if the piston has a smooth surface type of contact with the walls, what I'm saying is that now let's come to this part, right? So you see, if this force was up, this one will be down. So if you pick, so that's D. If you pick the cylinder, you're going to have this force in the opposite direction too. So this is FDB. All right. So we are still making an angle of what? 67 with the horizontal. So 67 will be here. Okay. So you're going to find the force acting at this end. But because the walls here are smooth, the only force acting on this cylinder is going to be this force here. And one the vertical component. So we're going to have FDB like this, and then you have 67 here. Okay, so the question gave you this line, and then you put 67 here. So you can bring it here to a 67, right? Alternating angles are equal. So knowing this, you know that the vertical is going to be what? FDB sine 67. Okay, so FDB is 597.597. So 597 sine 67. And that is giving you the horizontal vertical component, right? So the vertical force, or FDBY, to be equal to what? 549.54 Newton. And this is the vertical force that's expressed on the cylinder. So you're done for assignment 1. We are going to start or go through assignment 2. And yes, if the video has been helpful up to this point, let me know it in the comment section. If you have any question, let me know over there too as well. And if you haven't subscribed, kindly do so. So on to assignment 2.